In this exercise, we will set up our first SnapMirror relationship. It's going to be of the type DP, data protection, and we will first create the source and destination volumes, then a SnapMirror policy, then the DP relationship itself, and then we will initialize a relationship. So let's first create the volumes. We are going to create a 1 GB volume with the junction path src, and the name of the volume is also src. And then it starts complaining again about there not being any rules in the default policy, but we ignore that. We will fix that later. We create the second volume on the second cluster, which is going to be called DST for destination. It's also going to be 1 GB, and important, the type is going to be DP. If you don't specify type DP, then you will not be able to set up the relationship. You will have to remove the volume and recreate it. So we create a policy. The policy is going to be called SM_pol1, and it's going to be of the type asynchronous mirror. Now, very important, we have to add a rule to that policy to make sure that we take along all of the snapshots from the source volume. You can't set up a DP relationship if you do not have that rule in the SnapMirror policy. Then we create the SnapMirror relationship itself. We specify the source path, which is svm1 source, and the destination path is cl2 svm1 destination. The policy is smpol1, and the schedule is going to be 5 minutes. So that's done, and now we can initialize the relationship. Let's first have a look, and we see that the relationship is uninitialized. And mind about the type XDP, I'll talk about that in a second. So now we initialize a relationship and we check it again. So we see that the relationship is initialized and the type is XDP, even though we specified asynchronous mirror. So it always defaults to XDP, but it is a data protection relationship. Now we mount the volume because it can only be mounted after the baseline transfer is completed. And we're done for now. And in the next lab we will access the volume and make sure that we can write to the source volume and we cannot write to the destination volume. And we're done. Now we will create 2 mount points on the NFS client. We will add 2 data logical interfaces to the SVMs, and we will create an export policy and connect the export policy to the volumes. So we log into our Linux machine and we create 2 directories in /mnt. The directories will have the IP address host part 225 and 226. We log into our clusters again and we start creating the logical interfaces. So the first one's going to be called NFS-lib1, role is data, data protocol is NFS, IP address is 225 at the end, and that's the first one. Then we create the second lib on the second cluster, which is also going to be called NFS-lib1, role is data, data protocol is NFS, and the IP address is 226 at the end. Next, we create the export policies on both clusters and both SVMs. We will create the read-write policy. And we allow full access for all hosts. We also do that on the second cluster, export policy and full access for everybody. Then we connect the export policy to the volumes. Don't forget to also connect it to the root volume of your storage virtual machine, otherwise you will not be able to access anything. So we do that on the first cluster, we connect the volume and the policy together, And we do that on the second cluster as well, for the root volume as well as for the destination volume. Now let's mount the volumes to the client. So first we enable NFS on both SVMs. So we run NFS on for the SVM on cluster 1, and we also run NFS on for the SVM on cluster 2. Then we go to our Linux machine and we mount the remote file systems to the correct directories, 225 and 226. Now we will write a small file to the 225 source volume. And we run a SnapMirror update to make sure that we've got the file on the destination volume as well. And let's check that. So we check the destination volume and we see that that file is in there. So the update was successful. Now, to prove that we cannot write to that particular destination volume, we'll try to write a file and we'll get the error message that it's a read-only file system.